Morning everyone, we're here to talk about the Windows Update architecture, more specifically WSUS. But before that, let me just introduce ourselves briefly. Here's Yves, he works for the French National Security Agency. He works as a security auditor for more than 10 years now. And I'm Romain, I was a security auditor, but I'm now a developer in a small company dealing with Active Directory security issues. Before talking about the WSUS itself, I'll introduce you to a problem, a scenario that we encountered sometimes during our pen tests. So that's you, waiting to compromise a network, the network, and somehow you get a foothold inside this network. It can be by phishing or compromising a JBoss server or Tomcat Oracle with default credential. And as anyone knows, when you compromise this kind of server, it runs with system privileges because you have to. It doesn't work otherwise. So you pilfer the credentials on this server, you manage to do some lateral movements, and at some point, you just realize that everything you have, you're blocked. You can't go more in the network. But by looking at the information, the data that you get on these servers, you realize that there's another network, a disconnected one, next to the one you're trying to compromise. The problem here is that you don't have any more credentials to get more into the network. So you're basically screwed. But when you look at the servers you've compromised, there's a WSUS server, and the question we're gonna talk about in this talk is that what if you can use this WSUS server to compromise its clients, and more specifically, the domain controllers that are clients to the WSUS server? And to answer this question, we need to understand a little bit of WSUS architecture. So here you have a WSUS server inside the enterprise network, which is synchronizing its updates with Microsoft Updates servers. And this synchronization is done in two steps. The first step is to synchronize the metadata on an HTTPS secret channel. And the second one is to synchronize the binaries associated with this metadata on an HTTP channel this time. This can be a problem, but actually isn't because of the signature that any binary needs to have. We're talking about authenticated signature here. So no one can actually tamper with the binary, even if the channel is not secured by TLS. In the metadata, you have anything relating to the updates themselves, including the Microsoft bulletin number, the description of the updates, whatever the information. And the binaries can be anything from a PSF file, a cabinet file, or more interesting for us, an executable file. The executable file has a particularity because it can take command line arguments, and the command line arguments are provided into the metadata, which aren't signed. We'll see why this is important later. Then inside the enterprise network, you have WSUS clients. It can be workstation, it can be servers, from a filer to a domain controller, that regularly synchronizes with their updates with the WSUS server. They do it by default on an HTTP channel. Microsoft is really pushing forward to administrators to enable TLS, but it's not really often the case. The updates are obviously applied with full system privileges, because if you need to replace a critical part of your system, well, you need to have full system privileges to do that. In more complicated network, you have what Microsoft calls upstream and downstream servers. Think of a worldwide company with an internet access and one policy to manage updates. You can change servers, and the updates will follow the chain. And if you have even more complicated networks with disconnected ones, for example, well, Microsoft is providing a tool to export updates from a WSUS server to an external disconnected WSUS server. So that's a quick overview of the WSUS architecture. We're going to talk about now the state-of-the-art of the attack on WSUS, and it's going to be pretty quick because there's only one attack that has been presented at Black Hat USA 2 years ago now. It's called WSUSpect. And the idea of the attack is to get a man-in-the-middle position between the WSUS clients and a WSUS server to intercept the answer of the server, inject a fake update into the metadata stream, because it's on HTTP channel inside the enterprise network, and the metadata unsigned. And the clients then apply these new updates with system privileges, and that's how you get control of the WSUS clients. This really is an awesome attack because it's the first on the Microsoft update architecture, but it has some limitations. The first one is that you need to get a man-in-the-middle position, meaning that there's no network limitation in place, such as private VLAN, for example. And the second limitation is that you need to get a useful one. So here I presented you a not TLS-enabled network, but sometimes administrators do their job and secure these streams. In our case, it's difficult to put in place inside the network, the internet-connected network, but it definitely can be used for the disconnected one. So we developed our own tool, which is called WSUSpendu and is freely available on GitHub. The idea of the tool is not to have network limitations, but if you have compromised a WSUS server, you can inject metadata into the database and use the signed binary, we'll talk about that later, inside this WSUS server. And when the client will download this update, it will see a new update, and it will download this the binary related to this update. The first thing a client does when it downloads a binary is to check if the binary is signed by Microsoft. So you have to have a signed binary which can execute arbitrary commands. So the two most known binaries are psexec and bginfo. They were presented with WSUSpect attack. But actually you can find other binaries if you look at the app locker bypass projects, such as the one with subtip. So you can use, for example, msbuild or install-util, which are two other binaries which are signed by Microsoft, and that take command line arguments that execute arbitrary commands. So you have in the metadata command line arguments, the binary is signed. That's how you get the control of the WSUS client.
Okay, so we have some video to demonstrate what could be done with WSUSpendu. Okay, in the scenario, we have compromised a bunch of servers, but we don't have compromised the domain controllers. So we can use some servers to try to compromise the domain controllers. And among the control servers, among the servers we have compromised, there are WSUS servers. So we try to inject an update, a malicious update, to control all the clients. Here we are on a WSUS client. We have absolutely no privilege and no account on these servers. We can verify, and only the administrator account is present. The aim of the attack is to add new users on this computer. So as we have compromised the WSUS servers, we copy the binary, WSUSpendu and a payload, psexec in this case. on these servers, and we want to launch an injection. So we launch the injection of the payload, PSExec in this case, and with some arguments to add a new user. So we launch a command to add a specific user with a specific password. And while the update will be installed with system privileges, we take advantage of this to add the user in the local group, administrator local group. The last things we have to precise, we can precise, is the computer name of the targeted computer. By precising it, we can automatically approve the update for this computer. We can check in the MMC console, and after refreshing, we can see everything is okay, the update is present, and is approved for one computer among the 4 declared in the WSUS server. Okay, we go back to the client. And we have to wait the client check if a new update is available. We can force it by clicking on check for updates. And if an update is present, the system downloads it, install it with system privileges, and the update will be installed. That's it. So we can check now the user lists, and we can see the new user is present, and the user is a member of the administrator local group. So mission succeeded. Okay, we have compromised the connected network. We have compromised all the connected network, but we want to have a more intrusion in this the network. We have seen that another network is present, but this network is not connected to the current network nor to the internet. So we want to inject an update in the WSUS server present in the connected network, and we want to wait that an administrator transfer the update to keep up to date the disconnected network. So, as we have compromised, again, the WSUS servers in the connected network, we can launch the script, we can copy the WSUSpendu to perform an injection, and this time we want to launch PSExec, but the argument of PSExec is not to add a new user because it's not relevant to a disconnected network, but we want to launch a PowerShell, and the argument of the PowerShell is an uncoded payload. We'll see later what is this payload. This time we can't precise the targeted computer because no computer of the disconnected network is known in these WSUS servers. Okay, the update is injected. We can see it in the MMC console again, and everything is okay. Now we have to wait that a legitimate administrator has to perform his work to transfer the updates to keep up to date the disconnected network. To that, the administrator is connected on the WSUS server located in the connected network. Administrator transfers the update binary, and launch the WSUS tools provided by Microsoft to export the metadata from the database to an external device. After transfer the device on the disconnected network, you can import the updates. So to do that, you copy the WSUS content directory in the disconnected network and launch again WSUS to import metadata into the database. Now we can see the update in the WSUS servers located in the disconnected network. We can see some information like the classification, the update as a security update classification. We can see some other information like the Microsoft Bulletin, MS 1710. The bulletin describes the vulnerability exploited by WannaCry, and the description is set. All this information are controlled by the metadata, so by the WSUSpendu. Now, the behavior of the WSUS servers depend on the configuration of the servers. If we check in the option, we can see that a default automatic approval rule is set. This option is active, is present by default, but not active by default. In this case, the administrator just enables it. This rule says that if we are in case of security updates classification, the update will be automatically approved. So if it's not the case here, so the update will be approved for all the computers. Now we go on victim. A victim is a computer in the disconnected network, and we have to wait the victim search if a new update is available. We can force it again by click and check for updates, and normally the update will arrive, installed with system privileges, and if everything is okay, something will be open. Okay. Remember that the administrator just wants to update the disconnected network to protect again some ransomware as example, and after doing it, we can see the effect is a little bit different. As attacker, we just have to wait for money now. Okay, so we have compromised the connected network. We have managed to transfer an update, malicious update, to the disconnected network, and we have compromised the disconnected network. Okay, in conclusion, we can see that if we have WSUS servers in the network, we have control relationship from the WSUS servers to all these clients. So we need to be careful about the positioning of these WSUS servers. When you design a new architecture, we have to think about the WSUS servers. Thanks for your attention.